project 5.3. This is the project that deals with flip-flops and using them to build a clock divider and eventually putting that on the board to blink an LED. Alright, so the main idea behind this one is using a D flip-flop, which is kind of a modified SR latch, which we did in 5.2. You use this with a clock, and basically whenever there's a positive rising edge of the clock, whatever D is will get written to Q. Okay, but if you configure it, and all the code is given to you in here for the D flip-flop and the behavioral, it's described behaviorally. So if you modify it slightly and you put this feedback loop with an inverter, this is what leads to the clock division. It's mapped out over here. So on the rising edge of the clock, whatever D in is gets written to Q, or the clock div. So it's low here, therefore clock div goes low, but there's this little bit of delay here because of the inverter. So after that little bit of delay, DN gets updated because clock div just got updated, and it goes here and gets inverted. So if you follow this pattern all the way through, it's just a repeating pattern, but the idea here is that this cycle is exactly twice the period of the cycle, or half of the frequency. Therefore, it is a frequency divider. Okay. Now, if you link a whole bunch of these in series like this, where the clock divider is fed into another clock, you can continually divide the frequency in half, and you can bring it to a desired frequency if you wanted to. Okay, so that is exactly what we do in this project. It tells you to implement the clock divider to blink an LED, and let's open up my project. Open it up. Project 5.3. So here is project 5.3. Here's my implementation. So we have the wrapper in here. So this is the code. It gives you most of this code, and it has these wires that you used in the wrapper here. So you use DN and clock div to connect all the different slices of the D flip-flops, and use this generate loop to go through and make all the flip-flops that you need, 26 of them. Instead of going through and doing all of them, you can just do this loop and it generates it for you. Here's the inversion thing, and then you can do it their way, and it's just copy and paste, and you can put it on your board and see that since you assign the LED to the 26 clock division, it gets divided 26 times, 26 times, or 27 times, and so 100 megahertz divided by 27 is presumably that. Then it later asks you in the test your knowledge, which you asked us to do, to assign switches to change the frequency depending on the switch. So I did that. Basically what you do is you assign the switches to different clock divisions here. So since this is a bus of clock divisions, you can just assign the different switches to those buses, to the like the 26th input or the 25th or 21st. So that's exactly what I did. If you go here and you go to, if I wanted to configure target device, and put it on my board. Let's see. I will do that, and I'll show you how I implemented that. But right here is my code for it. I just used a case. I described it behaviorally with this sensitivity list here, where the sensitivity list is just the switches, and I define the switches up here as an input, a bus input, and when it's 0, 0, this is exactly what it says to do. I get to the 26th division bus, which is 0.745 megahertz. Anyway, let's get it on my board so I can show you real quick. So I've got the boundary scan here. Let's initialize the chain and do that. Now, 1 second. Let's go to assign new Verilog file. Go find the bit. There's the clock divider bit, and this device. Here, let's program it to the board now, and then I'll show you. I'll demonstrate how it works. Okay. So it says here when switch is 0, that's 0, 0. This is, let's go put it here, and let's put this here. So 0, 0, 0, 1 is the 25th, 1, 0 is the 24th, 1, 1 is the 23rd. And you can see that those correspond to different frequencies on here. So the 26th has the 0.745 hertz, 25th is 1.49, 24th is 2.98. Okay, and those same frequencies are the ones listed here: dunk, 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 and dunk. So here I have the board. I have it programmed to the board now. You can see when it's 0, 0, it's the 26th. When it's 0, 1, it's the 25th. It blinks twice as fast. When it's 1, 0, it's the 21st. So it'll blink even twice as fast as the current blinking. And then when it's 1, 1, it'll blink twice as fast as that. There it is. Boom. And that was thing for this project, and the hardest part was just coming up with this behavioral code right here. It gives you the rest, and that was the whole thing. Thanks.